we have to study the next topic, that is the absolute value. What is absolute value? That is, if x is a real number. Condition is what? If x is a real number, then absolute value of x is what? Is its distance from 0 on the number line. That is, on the number line, the distance of the number x from the 0 is simply what? Its absolute value. So the absolute value is denoted by what? Simply mod of x. This is a symbolical representation of the absolute value, and it is read as absolute value of x or modulus of x. Modulus of x. In the three cases we can define it. That is, first one, if x is greater than 0, then that is greater than 0 means what? It is positive. Then modulus of x is what? Simply x. That is the positive. Second one is what? If x equal to 0, then modulus of x, that is simply what? Equal to 0. That is the distance from 0. So x is 0, then what will we get here? That is 0. Third, if x is less than 0, that is at the negative side, that is the left side, then modulus of x is what? Simply a minus of x. Now let's see the practice set 2.5, which is based on the topic absolute value. The first question is find the values, but before that we will require the three all possible cases of the absolute value. If x is greater than 0, then modulus of x is what? Simply x, positive x. If x equal to 0, then modulus of x equal to 0, and if x is less than 0, then modulus of x is what? Minus of x, that is negative x. So these cases we will require. So first of all, here is what? Simply first of all do the subtraction. 15 minus 2. 15 minus 2 is what? 13. Now here 13, that is equal to, if you consider it as a x, x is what here? X is greater than 0, then it we have to do simply a positive x, that is simply answer is 13. Now here do again subtraction, that is 4 minus 9, that is equal to minus 5. Here the value of x is what? Minus 5, that is less than 0. So if it is less than 0, so what we get here? Minus of x. So what we do here? Minus of minus 5, that is equal to plus 5. Then in this case, that is third example, here the value of x is what? 7, that is greater than 0. So if it is a mod of 7, so we do here positive sign, that is 7. 7 multiplied by, here the value of x is what? Minus 4, which is less than 0. So what we give if it is in the mod, so we give simply a minus sign, that is minus of minus 4. So 7 into minus of minus 4, that is equal to plus 4. 7 for the 20th. In this way we can simplify the given examples. Now see the next second example. Now we have to see the second example of the practice set 2.5. Before that we have to see the absolute value of the any real number is never negative. It means what? It is a positive. Now here we have to see the second example, that is solve. First example is what? 3x minus 5 equal to 1. Now here is what? In the example, LHS and RHS, two terms are given. So while finding the value of x, we have to consider here there will be two possible values of x. That is, first of all, we have to consider 3x minus 5 equal to 1 or 3x minus 5 equal to minus 1. So here possible values of the 1 will be what? Minus 1, or it may be a plus 1. Therefore 3x, here minus 5 there, if we transpose to the RHS, it will get plus, that is 1 plus 5, or 3x equal to minus 1 plus 5. Therefore 3x is equal to what here? 6, or 3x is equal to what here? Minus 1 plus 5, that is 4. Therefore x equal to 6 upon 3 or x equal to 4 upon 3. That is simply x equal to 2 or x equal to 4 upon 3. These are the two possible values of the x. Same type we can solve the second example. So therefore 8 minus x upon 2 equal to plus 5 or 8 minus x upon 2 equal to minus 5. Now here 2 is at the denominator. If we transpose or shift to the RHS, it gets to the multiple of 5. That is 8 minus x equal to 5 into 2 or 8 minus x equal to minus 5 into 2. Therefore 8 minus x equal to 10 or 8 minus x equal to minus 10. Therefore, what is the value of x? Minus x equal to 10 minus 8 or minus x equal to minus 10 minus 8. Therefore, minus x equal to plus 2 or minus x equal to minus 18. If you multiply the minus x to the both equations, what we get here? X equal to minus 2 or x equal to 18. These are the two possible values of the x. Now let's see the fourth example. Therefore 5 plus x upon 2 equal to 5 or 5 plus x upon 2 equal to minus of 5. Therefore, transfer this plus 5 LHS 5 to the RHS. So what we get? X upon 2 equal to 5 minus 5 or x upon 2 equal to minus 5 minus 5. Therefore, x upon 2 equal to what? 5 minus 5, which is equal to 0, or x upon 2 equal to minus 5 minus 5, that is equal to minus of 10. Therefore, x equal to 2 is at the denominator. If we shift to the RHS, it gets multiplied to the 0, and 0 multiplied by any number is always 0. So x equal to what here? 0 or x equal to minus 10 into 2. That is x equal to minus 20. Therefore, the two possible values of x are x equal to 0 or x equal to minus 20. In this way, we have completed our practice in 2.5 in the chapter number 2, that is